All right, so now we're going to tackle a minimization problem because we're trying to find the minimal cost for the dimensions of this box. Previously, we've been doing maximization problems where we're trying to maximize the enclosed area or volume or whatever. Minimization problems are still fundamentally the same as maximization problems, but it'll just be like a slightly different flavor. So we are talking about a box once again. And so the volume of a box is going to be length times width times height. However, we're given that our base length is 6 times the base width. So it's going to be 6W times H is going to be our volume. And so then for our surface area, I always like to draw different squares for my surface area. So if we think of this as 6W, this is W, and then this is H, we are going to have 2 boxes with the dimensions 6W and H. 2 boxes with the dimensions W and H. And 2 boxes with the dimensions 6W and W. So what does our problem say about this? So the sides is $3 per square inch. So these 2 are sides, or I guess those 4 sides are going to be their sides. And then this, since, notice that this is literally just our base, right? 6W and W, that's like literally just our base. So this is going to be top and bottom. 1 for the top, 1 for the bottom, hence why there's a 2 here. So the cost is going to be an adapted formula of the surface area. The sides is $3 per square inch. So it's going to be 3 times 2 times, and the area of this is going to be 6W times H plus 2. Area of this is going to be W times H. And then for the cost of the top and the bottom, we're talking, what was it, $15 per square inch? Yeah. So that's going to be times 2 times 6W times W. So we can simplify this to 3 times 12WH plus 2WH plus 15 times 12W squared. And then that's going to be 3 times 14WH plus 15 times 12. 180 W squared. So then this is going to be, and we're still talking about the cost. So this is going to be our, well, I guess we could do 3 times 14, which is 42 WH plus 180 W squared. All right, so this is our cost formula. So now we want to find a way to insert our volume into here. So one way we can do this is, first let's rewrite volume as 6W squared H. And notice how we are given information about our volume. The total volume that our box is going to enclose is going to be 20 cubic inches. So we can substitute 20 in here, and then we can solve for H. Generally, you always want to solve, you do not want to solve for the thing that gets squared, because then you're going to have to take the square root of both sides, and you're going to have a plus or minus, and it's going to get all ugly. So we want to solve for our H. So H equals 20 divided by 6W squared. And let's just simplify that to 10 over 3W squared. All right. So then let's just substitute that in for H. C equals 42. W times, what do we say, 10 over 3W squared plus 180 W squared. So then C is going to equal 14, because this 3 is going to make this 14, times W times 10 over W squared plus 180 W squared. So then we can rewrite that as 140. This w up top cancels with this w squared, makes that just a w. So we just get 140 divided by w plus 180 w squared. So now we're about ready to take the derivative of this. So let's do that. C prime equals 140 over w. Derivative of 1 over w is going to be negative 1 over w squared. So that's what we're going to get for that. And then this is going to end up being 360 times w. So now we are going to look to make a sign chart. We want to make a sign chart with these values because that's going to give us our intervals of increasing and decreasing, and therefore our local maxes and our local mins. So in order to do that, we got to set the whole thing equal to 0. So then we can just move this 140 over w squared over, set it equal to 360w. We multiply both sides, or I guess we divide both sides by, actually wait, let's multiply both sides by w squared. So 140 equals 360w cubed. So then w is going to be the cube root of 140 divided by 360. So then we can start by taking those zeros out. So it's going to be 14 over 36. W equals the cube root of, we can take a 2 out, 7 over 18. So that's probably as simplified as we're going to get. So that is going to be the value that we will put on our critical chart, or sign chart. That's going to be the critical value that we put on our sign chart. All right, great. So now if we plug something if we plug something to the left of this into our function, we are going to get, and we're looking at a regular C prime. So if we plug -1, that's to the left of this, right? So if we plug -1 in, plug in a -1 here, that gets squared, that becomes positive. This negative makes this term always negative. This is going to become a negative. So that's going to be a negative plus a negative, which is always going to give us a negative. And then it's going to be positive over here. Okay, so then that means we have a local min here at this w value. So now we can be like, okay, since we are decreasing from negative infinity all the way up to this point, and then we are increasing from this point all the way to positive infinity, this is the only possible place we could have an absolute min. So our absolute min has to be here at this local min. So this w value is going to be part of our final answer. Now we just have to substitute in our other values. So if we recall, our length is 6 times our base width. So all that means is that L equals 6 times our w value. That's all it means. And then our height is going to be a little more difficult to solve. We're talking plugging it back into here. 20 equals 6w squared h. 20 equals 6w squared h. So if our w is the cube root of 7 divided by 18 times h, then h is going to equal 20 divided by 6 cube root of 7 over 18. And I'd say generally on a quiz or an exam, that will be an acceptable way to leave your answer. So these are all three going to be part of our answer because we need to list the dimensions.